Hello, in lesson 15, in the previous one, I was talking about enforcing contracts with interfaces. We would write a class that implements one or more interfaces. Today I would like to enforce this message about interfaces. I'd like to show you another example or examples why interfaces are useful, why programming to interfaces is great. So just a little bit more information. In the previous lesson I was telling you that it's great if you will think it over up front. What is the class, what method it's supposed to do, what is the functionality of the class. In this example, in this slide, you see that I have an interface product, just a type, and I have an interface product service. Imagine that you need to write some class that's supposed to have a couple of methods. Get products, which will return you all the products. What the method does inside, it's not that relevant. It makes a request to some server, probably requests all products, and it'll get JSON with all the products. And it's supposed to have a method get product by ID. In this case, you are expected to pass an ID of the product and get back the data only about the selected product, the product that corresponds to this ID. So we can define a couple of types, interface product and product service, and then we say class product service implements product service. That's great. This is how we are supposed to do things. Up front, think about the interfaces and enforce the contract by implementing the interface. Right? And then sometime later, you decided to do another class product service. Why? Because the backend guys are not ready yet. So you are supposed to hit some endpoints and get back the data from the server about the product. But the server is not ready yet. So what are you gonna do? You're gonna help yourself. You're gonna say, you know what? I want to create a mock class for product service, and this class will also have the same method like get products and get product by ID, but it'll return me hard-coded data. Till the backend guys are ready, I want to keep moving. I want to keep programming my front end. So what you can do, you can say class mock product service implements product service, which is an interface, right? We are enforcing the class mock product service will have the same exact public interface, which is two methods, get products and get product by ID of these signatures, right? And since we said implement product service, it must implement get products and it must implement get product by ID. That's great. That's how it's supposed to be. And by the way, even for testing purposes, working like that helps you in easy switch between the real class and the mock class. You might be using mock classes for unit testing, for example. And you should be able to easily switch between one and the other, between the real dependency and mock dependency. What does it mean, dependency? Dependency is something that another class or a function or a method depends on. For example, you may have a test script, you may have an application function that uses product service, for example, and this would be a real dependency. For testing, we don't need a real service. Actually, for unit testing, we don't need to hit the real server. We can use mocks, and we can say, now, you know what, now we use mock dependency. If you'll go back for a second, we can still say we want to use product service. It's something of type product service. And the fact that class mock product service implements product service, we can say that this something is of type product service. I believe I mentioned this in lesson number 15. If you missed it, go back and see how you can declare a variable either of the class type or of any of the interfaces that this class implements. This slide is from Angular. Angular implements dependency injection. We will not go into that. That framework can create objects and inject them into, for example, UI components. And we can switch between injecting mock services and real service. But now, let's continue with this example, but let's say we didn't think about it from the very beginning that programming to interfaces is great, so we would program to concrete implementation. So we had some class product and we had class product service. It's already written, no interfaces, right? And this class product service happened to have a couple of methods, get products and get product by ID. That's great. And now the time has come, again, the same scenario. Backend guys are not ready, or I want to develop some unit tests, and I want to create a class mock product service. And now there are two cases, since we did not program to interfaces in the first place. On this slide, take a look. I don't have an interface product service. I cannot write that mock product service, implement that interface. But still, actually, one second. So what are the choices that I have? The first choice is if I am an experienced developer, I would look carefully at this class product service. I would notice that it has two methods, get products and get product by ID, and I would be nice to implement exactly these methods in the class mock product service. But I don't have to go this route. I can find a difference. I could do it differently. So I can say, look at this. I can say class mock product service implements product service. Am I crazy or something? Where is an interface product service? I didn't even declare it. This code was written a long time ago and I didn't declare an interface. So what do we have over here? A class implements a class, right? This is weird, especially if you have background in Java or C#. A class implements a class. What is that? In TypeScript, you can do this. If you will write class A implements class B, it means that class A, in this case mock product service, must implement all these public methods from class product service. So technically, it is smart enough to understand TypeScript that when we say a class implements a class, technically we want to enforce the contract. So all public methods that were defined in product service class will be implemented in mock product service. See, so there is still a way out, even if you didn't do things right from the very beginning. Now, let's talk about factories. Programming to interfaces. Again, keep this mental model, or have this mental model. What are the factories or factory pattern? In some cases, you need to write a function that will return you some objects. But this function can return you an object A or maybe B or maybe C, depending on some condition in there. So how would you program factories? And what interface has to do with this? Let's take a look. Again, we keep considering this example with product service. Once again, I have an interface product, which is just a type, and then I have interface product service, which defines two method signatures, get products and get product by ID. That's fine. And then I have a function. This would be a factory function. I have a function, and see, it has one parameter, is production of type Boolean. Let's say if I run some app in production, this function should build and return the real product service. If it's not production, this function should return a mock product service. See, this is a factory function because it analyzes something, and depending on the value of this variable, in this case is production, it'll return one object or the other. It'll build like a factory. It'll build either one object or the other in this case. So, and take a look what this function returns. We say it returns product service. By doing this, we are saying, or we are certain that product service, mock product service, or maybe another product service, they all implement this interface. That's why we can use it as a type over here. We can say, I know that this factory function may return many different types of objects, depending on certain conditions. In this case, it's only 2, it can be more than 2. But I know for sure that each of these objects that can be possibly returned from this function implements product service. That's why I can use it as a type. I use this interface as a type. These objects may have 25 other methods. I don't care. I'm saying that this factory function returns something that definitely implements product service. And this is what I care about. So later after this function, I say declare a variable product service and say I hard code the is prod to be true. Realistically, I would read it from some environment file that would know if it's production environment or not. And then I say give me the get product service. I invoke the factory function. I pass the value is prod, which could be either production or maybe development or maybe QA, and then I get it in the variable product service, and then I can invoke the API of this variable of this object basically that is defined in the interface product service. So that's the factory. And now I want to show you a little example. I want to compare how things are done with interfaces versus without interfaces. So you can see the advantage clearly. I will compare one fragment from Angular framework with Vue.js library. Without going into detail, you don't need to even know these frameworks to understand what I'm about to say. I'll just tell you that both of these frameworks are component-based. So an app consists of components. And every component has its life cycle. A component gets created, some things can happen in the component, it can be rendered and different things. And then the component gets destroyed. This concept is the same in Angular, in React, in Vue, very similar. But how do you know if a component is at a certain point in its life cycle? These frameworks can give you so-called hooks or callbacks. The framework tells, like in this case, this is about Angular. It says, see these functions or methods? A component is represented by a class. They say, if you want to catch a moment which is of importance to you, like in, for example, ngOnInit. ngOnInit is a method on the component that will be called by the framework, by Angular. When the component and its properties are initialized. Angular documentation says that this is if you want to catch this moment, implement a method ngOnInit on your component, and we guarantee you that we will invoke it. So your code that you put in there will be invoked. And Angular documentation says, if you create an application, if you create a UI component, in this case, let's say app, I called it, implement the interface. In Angular, they say there is an interface on init. which forces you to implement one method and G on it. And similarly to all these other methods. For example, there is an interface on changes. Accordingly, you must implement one method and G on changes. There is an interface on destroy. Accordingly, you would need to implement and G on destroy, and so on. All right, so no rocket science, right? Implement on init, and because of that, you have to include in your class, in this case, UI component, the method and G on init, and do something in there. In Angular, just to let you know that ng on init is the right place to invoke, to populate the UI component with some data. Why? It's irrelevant in this case. Now we go to Vue.js. Read documentation about Vue.js. They also have hooks, and they say we're gonna invoke these hooks or callbacks when the appropriate write in the life cycle of the component when the time arrives. So in Vue.js, again, similar concept, but they have an event, or not event, the callback created. And they say if you will write certain code in the created callback, and once again, created in Vue.js is the right place to put code to maybe to make a fetch of some data from a server. And they say put this code in the created callback. So you will write your UI component app, and you will make sure to write this method created and implement whatever logic you have. Kind of similar. It's similar, but there's a big difference. Angular itself, from the very beginning, was written in TypeScript. And they use this concept of interfaces and enforcing contracts with interfaces everywhere. So, but Vue.js, they didn't. At least at this point, we have version 2.6. The version 3 is in the works. The version 3 of Vue.js is rewritten in TypeScript, but not yet. The version that is used at the time of this video, which is what? Which is February of 2020. They did not create this library in TypeScript. They thought of TypeScript, but it was like an afterthought. So now let me show you the problem. If, say, in Vue.js, I made a mistake. I misspelled this word, created. Let's say I put double T in there. What will happen? You will have a bug. Your UI component will work, but let's say we put some code inside created method with two T's, with double T in there, that was supposed to make a request to the server and get some data. This method will not be invoked. Why? Because you invoked it. And Vue.js will check this component during the runtime and see, oh, does it have a method created with one T? No. The fact that you have created with two T's doesn't mean that Vue.js will invoke it. So you have a bug, and this bug will be caught only during the runtime. You will see it, and you will find it, you will debug it, and you will fix and remove this double T. In case of Angular, since they say if you are planning to implement these hooks, please declare on the class that it implements interface. And then the TypeScript compiler will monitor that thing, and it will check that you did implement the method and G on init as required by this interface. If you will misspell this method, let's say let's say you will decide, you will by mistake type ng on and another n, double n. TypeScript compiler will catch it immediately without running the app. Why? Because it'll see. Okay, they say that the class app implements on init. On init requires to have the method and G on init, but they enter something with double n. It's not the one, so the class did not implement the interface correctly, and you will see the compilation error right away. So that was it for programming to interfaces, and thank you for watching.